Alright, take 7. This is taking a lot more than I thought it would. Alright, let's see the game. Welcome to the dark maze. Enter 1 to see the rules. Enter a different number to skip. We'll look at the rules. Rules of the game. You've been trapped in a dark maze with nothing but a flashlight. Navigate through the maze until you find the key. Type 1 to move north, 2 to move south, 3 to move east, and 4 to move west. Once you have the key, return to where you started and escape in as few moves as possible. What color is your player? Type 1 for blue, 2 for red, 3 for a random color. Let's say I'm an idiot, right? I type 5. Invalid input, enter 1, 2, or 3. So it's going to keep asking me until I pick something that I can use. Let's pick 3, random color. What shape is your player? Square, circle, diamond, just diamond. What color are the walls? Pick another random color. And then here's our starting screen. Now before I start playing, let's explain how this all works. So here's our intro. Welcome to the dark maze. Rules, enter 1, anything else, skip the rules. Go skip straight to customization. Now for the customization, this is important. We use a while loop here, because it needs to ask the player for inputs until you pick something valid, like 1, 2, or 3. If you pick 1, 2, or 3, it'll break, and then it'll customize whatever your choice was. Say you picked 1, the variable player color will equal B, that means blue, red, or random color. So the ran function generates a random number between 0 and 1, and this 1 and 3 creates a 1 by 3 RGB matrix. And that's what generates our random color here. Looks like we kind of got like a turquoise color. And the same works for the player shape and the wall colors. It uses a while loop to ask until you input something valid. Now once you've got all that configured, it'll say successfully define the color of your maze, and then it'll plot this right here, what you're seeing. Subplot 331. So this is a 3 by 3 array of subplots, so a total of 9 subplots. This one is plotting the first one, and that's our maze and our player. At resting position 1, 5, our player is configured by player shape, that variable which we talked about earlier, and the player color. That's our random color generated by the RGB matrix. And for the rest of the squares, they're black. And I did that using a for loop. So for all of these 2 through 9, we're going to subplot and fill the entire square, the 6 by 6 square, K, that's black. And then here are the initialized variables that will change as the player moves around. So PL, that's the player location, he's in zone 1, so that starts off as 1. The count, that's our move count, how many times we moved around, that starts as 0, we haven't moved yet. KL, that's going to pick a random number between 2 and 9, because we can't have the key in zone 1, and it wouldn't be much of a game, would it? Keys equals 0, that's our key status. It's 0 because we don't have it yet, we have no key, we need to find it. And all of the animations and movements are nested within this while loop that checks for winning conditions. So if keys equals 1, meaning you have the key, and player location equals 1, meaning you move back to zone 1, then you win. And then it breaks and moves on to the winning cutscene. Here's our options for moving out of zone 1. If player location equals 1, while true, it's another while loop that's going to ask for inputs until you pick the right one. So in this case, you're in zone 1, you can only move east or south, so you can only pick 2 or 3. If you pick 1, it'll tell you can't move north. If you pick 4, it'll tell you can't move west. If you pick anything besides 1, 2, 3, or 4, it'll tell you pick a number between 1 and 4. So here's one possibility. If player location equals 1 and player movement equals 3, you move east. It'll increase the count by 1 because that's one move. And then this for loop animates the player movement out of zone 1. So we start at point 1, x equals 1, and then we end at x equals 6. And subplot 331, here's our maze walls, here's our color, here's our x and y limits so that everything stays within the same relative shape. And then we're changing our x direction here, and our y remains constant because we're moving in the X direction. And then we hold off. That way it doesn't, plot all of the points moving up to it. It'll look like the player is moving. And then entering our next zone, zone 2, we have to change all the black squares. So every square besides 2, 1, 3, 4, 5, 6, 7, 8, 9, those will become black now. And then here's our for loop that animates the movement from the beginning of plot 2 to the end, resting position of plot 2. Here's our walls. And once you move out of zone 1, there becomes a possibility that the key is going to spawn in somewhere. So if the key location is 2, given by that random integer function, and keys equals 0, meaning you haven't picked it up yet, the key will spawn in zone 2 at the resting position, and the player will move towards it. And then it will update the player location by 1. Now this is very important. When you move east, it'll add 1 to the player location because you're moving from zone 1 to zone 2. But if you move south, like in this one, it will have to add 3 to the player location because you're moving from zone 1 to zone 4. And if you don't keep track of the player location properly, this whole thing will not work. So the key retrieval, if the key location is 4 and the keys equals 0, let's say you moved into zone 4 and the key was there, you'll pick up the key, keys equals 1 now. So now one of the winning conditions is met, and it tells you have to make it back to zone 1. So once you make it back to zone 1, you'll win. And basically, it's like that for every square. Every zone has its possible movements out of it, and a possibility for the key to spawn in besides zone 1. And then once you find the key and make it back to zone 1, winning conditions are met, and we end. And this moves on to our winning sequence. It'll tell you, you won, it took you this many moves, thanks for playing. And then this variable here is count. That will tell you how many moves it took you to win. And then this for loop, this is a nested for loop that will change the color of all the plots besides zone 1 3 times. So it'll plot zone 1, where you ended at, and then the rest of them 2 through 9 will go through a sequence of switching to a random color. This is our RGB matrix again. And it'll pause 0.3 seconds, it'll do it again. It'll plot all of these colors, and then it'll do it again, it'll move up 1, it'll do it again, and then after a third time, then you'll end, and that's the end of the game. Now, let's do a little bit of moving around here. Let's move south. Oh wow, that was lucky. That was lucky. All right, let's move it back to 1. Let's move it back to zone 1. And then there we go. Our squares fill up with random colors. You won. It took you 2 moves. That's actually a record for me. Wow. And that's the game. Thanks for playing.